Okay, we are going to work on section 12-1A number 13, and we'll use GeoGebra to do this. And we could make our own triangle just by clicking the polygon tool and then measure all the angles and all the sides and work from that. Or we could open a pre-made one, which is what I'm going for. So I'm going to search for a triangle exploration. I'm just looking for one that has the sides and angles already measured. Okay, on this one, it lets us, it has a slider for the length of the red side, side CD, so I can make changes to that. And a slider for side CA and a slider for side AB. And you can see that the angles are already measured for me. So we have a question here. Is it possible to make a triangle with sides of lengths 2, 3, and 4? So let's just slide A. I'm looking at question B, 13. B. There's a 2. There's a 3. 4. So would you say, is it possible to make a triangle with sides of lengths 2, 3, and 4?
Yes.
Okay,
Yes.
you can also do this one just by the triangle inequality theorem. 3 plus 2 is greater than 4. 4 plus 2 is greater than 3, and 4 plus 3 is greater than 2. Okay, now on 13A, I'm noticing this is another pencil and paper construction that I didn't pay attention to, so you don't have to do the part A on this one.
Okay, so that was the one that we were working on that was a little confusing, but I thought that I had done it right in the other version of
Don't you-
GeoGebra, not the pre-made one.
So with a, we can do that with a compass and a straight edge. Okay, let's go to 13C. Can we make a triangle with side lengths of 4, 3, and 5? And if so, what kind of triangle is it? So we already have the 4 and the 3. Let's make the red one 5. Yes, it is possible. And what kind of triangle is it?
It looks like a right triangle.
A right triangle?
I would agree.
Yes. Scaling triangle, right? Scaling right triangle.
Scaling right triangle. Very good. Okay, for D, can we make a triangle with sides 4, 5, and 10? So we already have 4 and 5. Let's move B to 10. Possible?
Nope.
The line.
No, 4 and 5 is adding 4 and 5 together is not greater than 10.
You're correct on that. Okay, can we make an equilateral triangle with sides 5 centimeters? So can we put these all at 5?
Yes.
Yes.
Right? F, a triangle with sides 6, 7, and an included angle measure of 75. Six, 7, and between the green and the blue sides, can we get this alpha here to be 70?
No.
Do you think I would need to make that red side bigger or smaller if I want that angle alpha bigger?
You need to make it
Bigger.
Bigger. It looks possible to me.
6, 7. Oh.
Okay, can we make, we're on G. Can we make a triangle with sides 6, 7, and a non-included angle of measure 40?
What does it mean, non-included?
So non-included would mean the angle that is not between the side that is 6 and the side that's 7. So it's not talking about alpha, it's talking about gamma or beta. And can we make one of those 40 by adjusting X?
You're almost there.
No, it went lower than 40, it went higher than 40.
Oh, but you can't land on 40. Okay.
So it had to be exactly on 40, right?
Can you make it exactly on 40? I think you can.
Oh,
You're almost there.
As I'm sliding it here, it seems to work. I don't see any reason why not. Do you?
nope.
Double check ourselves in that.
So would a non-included angle be that? Could it also be that B one?
Yeah, it could be beta as well.
Oh, beta.
These are Greek letters.
What feature on GeoGebra did you use to construct this triangle?
I personally didn't do it. I opened up the triangle exploration.
Oh, triangle.
Reason. But I can tell the way they did it is they used 2 circles. One of the circles had a center at A and one of the circles had a center at B. And the 2 circles are intersecting at point C. Again, you could have used your own homemade triangle, but it's a lot harder to keep everything stable the way you need it to in order to do the exploration. So using a pre-made one is advantageous. Okay, we're good on G. G is yes. If you look in the back of the book, it's going to tell you how to do it by paper and pencil. Which we're not doing, we're just using GeoGebra. All right, H. Can we make a triangle with sides 6, 6, and a non-included angle of measure 40. So let's move B back to 6. Now can we slide A so that either gamma or beta could be 4?
Yes.
Like it'll be obtuse, but it's possible. I, a right triangle with legs 4 and 8. The legs include the right angle. I made B4. I made 6, 8, or C8. And now as I drag A, can I make a right triangle?
Yes. Yes.
And let's check that with the Pythagorean theorem. 16 plus 64.
$80.
80. So it would be the square root of 80. Which is very close. It works if I drag it before 9 and after 9. So yeah, it's that works. And then J. If the given information determine a unique triangle, explain why or not. Okay, let's go back to B. Given 3 sides, so side, 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 does that make a right triangle, or does that prove congruent triangles if we have 3 sides given in our 2 triangles? It's side, side, side that you can show that are the same. Does that make congruent triangles?
Wait, so the question says, just the given information determine a unique triangle? So what makes it unique?
So if you have 3 sides given, can you make a different triangle with those same length sides where the angles are different? Or is it unique?
Unique meaning that it would continue to be the same triangle?
Yeah, so like what we have here, we have a triangle with sides 4, 8, and 9. Can
Mhm.
I make a different triangle with sides 4, 8, and 9 where the angles are different?
I would think yes.
Ow.
I don't think so, because it would still be
No.
the same triangle, just rotate it.
Yeah, you can flip it, rotate it, but the angles will be fixed. They'll be the same. If you're given side, 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 that fixes it, forces it to be its own triangle.
So the answer then for that one will be,
It would be yes, by side, 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 you have a unique triangle.
okay.
All right, part C. You're given 3 sides. So does that determine a unique triangle?
Oh, that's also a right triangle, so that would be the same thing.
It's also given, you're given 3 sides that can't change, so that determines a unique triangle by side, side, side. Part D, we said that one was impossible by the triangle inequality theorem. Part E, you're given 3 sides of 5. So would that be yes or no?
That'd be a unique triangle.
Yes, it would be a unique triangle. Yeah. You have 2 sides and an included angle, so that's side, angle, side. Do you remember?
For some reason, I'm thinking no. Because it's giving the angle degree.
Okay, we went over in class on Tuesday
Oh,
the different conditions where you could prove triangle congruent. Side angle side is yes, it's one of those that if you have 2 triangles where the side is the same, the included angle is the same, and the other side is the same, they have to be congruent. You can't form any other triangle with different angles.
mm.
That would be a yes.
So that's a unique triangle.
Yep. You can't make.
And that's the side. You said side angle side.
Mhm. Right. Okay, G is you're given a side, side, and a non-included angle. So it's the side, side angle case. The bad word, if you read it backwards.
So that's a no.
Draw a picture of it here with what we've got on the screen.
Oh, now I
Okay.
see. If it's an
If
included,
you're
I-
given this side is 8 and that side is 7, it's saying, and you're looking at this angle right here. Does that determine a unique triangle? Now look what can happen with this other side.
equilateral triangle?
It could come down like this, making it a different triangle. So you have this side stayed the same, that side, oh wait a minute. Let me erase that and start over. Okay, we're gonna look at this side right here. This side and that angle. Those things are fixed. They're not gonna change. But you could draw the triangle this way, where you still have, this side is still 4. This side is still 7. This angle is still 29.99 degrees, but it's a different triangle. It's not a unique one.
Okay.
So on the side angle case that we have here, this side fixed, this side fixed, the non-included angle fixed, it does not determine a unique triangle. It could be more than one. Because you don't know how this other side will flap. Will it flap to the left? Will it flap to the right?
So the key word here is the non-included angle is what makes it
Non-included,
a
right,
unique.
non-included angle, and that's what you see here on side angle. You got a side, you have a side, then an angle. And if you're trying to show that 2 triangles are congruent, side angle won't do it for you because it's not determining a unique triangle. It could be more than one.
So if you have, is that always the case that if you have a non-included angle that it's going to be not unique?
Correct.
Okay.
Right.
Or if you have a ugly word, it's not unique.
Not unique.
Okay.
And we can't prove things not triangles. Okay, H. A triangle with sides 6, 6, and a non-included angle measure of 40. Now on that one, initially you might say no, it won't work because you have side-side angle, but because you have an isosceles triangle, you can figure out the other angles and see that it is unique. So if we have 6, 6, and a non-included angle of 40, that forces this one to be 40. And 180 minus 40 minus 40 is 100. So that's fixing it. You have side angle side. Yeah. So that would be,
Okay, so if it's a non-included angle that's there, the SSA only works if the two sides that are listed aren't equal in length. Is that right?
mhm.
Okay. So then that's a.
All
That's,
right, wait, say that last part again now.
This one, we just had more information given to us in that the sides are equal, the 6 and the 6.
Okay.
yes, it is unique, right?
Mhm. But the reason it's unique is because it's by side angle side.
Okay.
Okay, by telling us we have an isosceles triangle here, it's fixing all the angles in that triangle. There is no ambiguity.
Okay, I had written that one off. Okay, so I'm glad we went over that one because I wouldn't have understood. Okay.
If I draw, I can draw it better now that I know that angle is 100 degrees from doing the calculation. We can see it a little better. So we've got 6, 6, and 40 right here. But since it's isosceles, we know that this angle has to also be 40 and this angle has to be 100. So there won't be a case that it flaps to another angle measure. It's all fixed.
That just kind of makes me laugh thinking about a side flapping in the wind.
Yeah.
Well, I think that was the problem that Susan and I had earlier because I picked one that wasn't a complete triangle. Because remember how you had the one the other night that was just like flapping?
Hanging there.
So I was trying to make the triangle and I was like, Susan, I don't understand how we're supposed to make a triangle out of that loose arm. So I picked the wrong the wrong pre-made triangle.
Yeah.
So I 100% see it now. So I
Okay,
would not have
good.
figured it out without this.
Okay, so that one was H. Now we have a right triangle with legs 4 and 8, and the legs include the right triangle. So what condition is that if we have an angle in between two known, if we have a known angle in between the known legs,
Side angle side.
right angle side, so it's unique.
Well, also because it's a right triangle and you can figure out the other leg, it could also be the side, right?
Yeah, you're exactly right. You could use the Pythagorean theorem to find the other side and then call it side, side, side. Very good, Aaron. Very good.
Thanks. It's Pi Day, it's getting the best of me.
There we go.
Okay, so I have a question. Is a problem like this going to be on a test where we can go to GeoGebra and do this, or what?
Wow, that is a really good question. Are you allowed to use GeoGebra on the test?
Because we can't put it on an index card.
I would say no, you can't use GeoGebra, but you could draw this on your note card. You can put anything on your note card.
Like just drawing out the triangle.
Yeah, just draw yourself an example.
Speaking of test, is the test going to be about chapter 13 and this current homework?
No, it's only over the chapter 13.
Chapter 13. Okay.
Okay.
I have a question. Was number 11 omitted or we doing 11?
It was not omitted. Let me look. I need to write down 13A. I did not look at 13A carefully enough when I was looking over what could be omitted. Okay, number 11. Use any tool to draw a triangle ABC in which BC is greater than AC. Measure the angles opposite BC and AC. Compare the angle measured. And repeat for a different triangle. What did you find? Okay, let's use GeoGebra here. And I'm going to just use, well, let me see, can I use the exploration that we want BC to be greater than AC? Oh yeah, we can use this one. It's only nice. But I need to take off my annotations. Okay, use any tool to draw a triangle ABC in which BC is greater than AC. So here I have BC is 7 and AC is 4. So we've got that. Measure the angles opposite BC and AC. So the angle opposite BC is 61.03. And the angle opposite AC is 29.99. Compare the angle measures. Repeat it for a different triangle. Okay, so let's be 5. So this time, BC is still greater than AC. The angle across BC is 60. The angle across from AC is 38.21. What did you find?
So when I did this, I did it in GeoGebra and I drew my own. And I did both of them. What I found was, and I hope I'm right, was that the longest side was opposite the angle with the biggest measurement.
Right. Very
Is
good.
that right?
Yep. Good job, Susan.
Woohoo! Give me a cookie.
Pi Day.
Oh wait, give me a pie.
Aw, what kind?
See, I can do this when I want to.
Based on your findings, make a conjecture concerning the lengths of sides and the measures of the angles of a triangle. And what you just said was the conjecture. With the longer sides, we'll have bigger angles opposite.
Look at me go.
In order. The small, medium, large sides have the opposite angles, small, medium, large.
So I know what my problem is because you have a whole lot more options. Like when I open my GeoGebra, you got like you had like a ton of you went through and you found triangles that had measurements and all.
Don't put the S on the end. That's how you get more.
Triangle exploration.
Yes.
Oh, really? Okay, that's exactly what I did then. How did you figure that out? You were good on
Because I forgot to type the S in the first time and I came out with 1,000. I was like, oh gosh, what am I supposed to do here? So then I added the S and
Put it in
Really?
there. Let's see what happens when I put triangle exploration.
Oh my gosh, you're so right.
Oh, wow.
Seeing you got yeah. Okay. Thank you. I wouldn't have figured that out, guys.
see,
Thank
I'm on the ball today. Now
It's-
tomorrow might be different.
It's Pi Day, man. You were good. Okay.
Did you do anything fun at any of your schools for Pi Day?
We went to the rodeo.
That is not math related.
It is not math related.